Hi, today I would like to introduce to you Gallama UI, which is a companion front-end for the Gallama library. So basically what it does is it's trying to bring the artifact feature, which probably you have seen it in Cloudy, as well as thinking, which basically try to induce the LLM model to think before actually it generates the answer. So this is local model only. This front-end doesn't work with Cloudy or OpenAI or any of the public closed source model. It runs with local model, and the preferred engine that we run this is actually Gallama. So before going into the detail of how this actually work, right? We can take a look into a demo first on what this front end can actually bring to you. So let me start with a greeting to the model. So here I'm running Coaster model from remichu-ai. Let me just ask it a coding question. So you can see that here in the answer, right? It generates the code in the artifact mode, as well as provided certain explanation. So it actually used thinking to plan out the answer before I actually answer. I will dive into more detail into this later on, but here's what it's like. What you're seeing is in real time. My system is running on NVIDIA 3090 as well as 4090. So next, before we go into how this front end actually work, let's take a look into how the thinking as well as the artifact look like in the closed source provider like Cloudy. So when I ask this question, you can see that it actually generates in the artifact mode. So it's similar to what we have over there, and it does generate some explanation as well. Actually, Cloudy using thinking to actually generate this. So here you can see from their documentation, right? They actually explain to you how you can use chain of thought prompting and like step by step and so on. It tells you that you can use like tag like thinking, answer to separate reasoning and final question and so on. We actually have example. So actually I really like them, that they are very transparent about all this as well. So now let's go back to Gallama UI, and here inside the setting, actually currently only Gallama working with the API setting. It doesn't require any API key, just put anything here. By default, the front end we just put some keyword here. Here we have temperature, there's system prompt, and here's a thinking template that actually the model used to answer. There are a few different settings here, whether to turn on the artifact mode or not, and whether to use thinking or show thinking or not, because sometimes we might not want to show the thinking chain of thought at all. Here in this return change of thought, just keep it to separate. And here I have a few different default template for you to use. If you choose any, you can just click here and load the template. Okay, and this is for the artifact. This can be anything as long as a valid XML format. Here in the model management, so you can see I have one model running, and this is on my PC currently that I have all these models that I can load. And the model management actually support multiple model as well. So if you can actually if you have enough VRAM to actually handle it, you can just load more model and select between them for the generation. It's actually in the roadmap to be able to have a mixture of expert feature where it can actually load model from like generate from multiple model at the same time and actually combine to give the best answer. It's in the roadmap, but it's not implemented yet as of now. So I also just like to quickly explain what the parameter here mean. So max sequence length is the max length that the model context can handle. Usually you just leave it blank. It will automatically take the model max sequence length unless you want to set it to a lower number. So you can set it here. Cache size. So when the model generate, actually it use cache to store the KV key value cache, and this is stored inside VRAM as well. So you, by default, the model will initialize a cache enough for the sequence length that we have here. But if you have extra VRAM to spare, you can set a higher number than the max sequence length. Another setting here is cache quantization. So by default, it using 4-bit. So what happens is the cache actually can be quantized also, and this will save the VRAM a lot. So there are a few options between 4-bit, 6-bit, 8-bit, and 16-bit. So GPU, you can leave it as auto. But if you have multiple GPU and you want to specifically select how the model being loaded, right? You can do something like this. Let's say you have like 40, 90, 3090, like what I have. You can do like, you know that the card will have like 24 gigabyte, right? But usually we need to reserve some, especially for the cards that use for the display. So usually that will be the first card. So maybe I give it more room, something like this. Then the second card I give like 23, and maybe my fourth card or 23. So something like that. Or you have a faster card and a slower card, right? And you want to skew more toward the faster card, you can always do, for example, like this. So just remember to fill in 0 also for the other card. Let's say you only want to load the model on 2 cards, then you should put 0 also for the other 2 cards, for example. And tensor parallel, it helps to make the generate faster. Currently only support for Crane 2.5 and Llama 3.1 7TB and Mistral large, because only these big model actually have benefit from tensor parallel. For the smaller one, we actually can have like faster generation from like 1 GPU. So here we can load the draft model as well. So normally there's only, I would recommend only use draft for mostly for coding tasks, and only for the model that have a company lower size of the same family. Let's say for Mistral large, you can get Mistral version 0.3, which has the same vocabulary to use. And then for Crane, of course, you have the 7B version and the 1.5B version. For Llama, you also have the smaller version to use for the draft. And for draft, you can also set the quantization. So I think artifact is kind of self-explanatory, okay. But what happened behind the scene is the backend Gallama actually enforce certain format restriction, so that the model written in a way that is more likely to be the correct format, so that the front end can detect the artifact. But how the thinking actually come into place? So let me show you this same example without the thinking at all. Okay, so let's say we take off thinking here, we start a new conversation. Okay, so you can see here that it answered the question by providing the quick sort implementation, which is correct. But if you notice, the answer here is different to the previous answer that we got, right? The previous answer is something more like cloudy, where it actually will give you the code and add some explanation for the code as well. So this is where thinking come in. It might not be simply like guide the model to think more or generate certain chain of thought before answer, but it can also allow us to guide the model to provide the answer in the way that we want. So here you can see that actually when Cloudie they provide the answer, it provides the answer as well as some explanation of the code. And I think if you use Cloudie enough, you notice this pattern in the way they answer, right? And it certainly comes from training. So again, this generation of artifact as well as the way answer actually come from the way they do the reinforcement training to tune the model to answer in a certain way, right? So how do we at least try to simulate what they have? Is we can use thinking in this matter. So let me show you the thinking template. So this is the artifact template. Right. So what it does is it asks the model to kind of repeat the task at hand. And I think there's some research that actually show that it help to improve the answer. This it actually guide the model to know whether the answer is actually will require artifact or not. Okay, so let me just modify this a bit. Let's say I modify it to be like this. Okay, so as you can see here, the updated artifact actually more or less the same. It's just that I remove a few of the pointer. I will just text an artifact. So let me ask it another question. Okay, so you can see that here it actually answered the question, but it's not yet what we want, right? If we see the answer from Cloudy here, actually it has the explanation for the code, and I believe if I ask it to write in Python and C# as well, it will have something similar. But you can see the answer here is a bit too concise and not really like how we want it to be. So this is where a small change in the prompt for the thinking can goes a long way. So if you notice the guiding prompt for the artifact, right? So here I just have acknowledge the question and summarize the content for the artifact and add more. But if you see the default template that I have, it actually say explain or elaborate on C2 and so on. And of course it can add more if needed. So actually this simple structure, while still being very open, will actually guide the model to behave more like Cloudy. So here you can actually see that it doesn't really work well, and this is because the model cannot really handle this long of a prompt. Now try to use a different model. Let me try to unload Costra and load the new 2.5 72B. Okay, let me just go with tensor parallel as well. Okay, I'll skip ahead to when the model complete. Okay, now that I loaded, let's try again. So what you are seeing here is in real time. And you can see that the way it answer, it actually has a certain explanation for the artifact as well. And same for the C# implementation. So one of the things is actually this does add a lot to the context that the model need to handle. So generally you will need a bigger model to actually be able to effectively use the thinking as well as the artifact together. From my practical usage, I think minimally you need something like Costra 22B or at least around that range for it to start working. The best could be the 70B model like what I'm showing here, or Llama 3.1 70B or Mixture Large. Let me just show you real quick also. Just now what you are seeing is at about 19.8 token per second with Queen 2.5 on my system. Okay, now let me just touch on a bit on the installation. Firstly, you will need Node.js. and you can install it from the official website, depend on respective platform. After you have Node.js, you can clone the Gallama UI here. From this URL, you can just copy here and clone it into your. So after you install it already, you just navigate to where it is in your laptop or PC, and firstly you run npm install so that all the packages are installed. After that, just run npm start. One thing is you need to have MongoDB, which you can easily run using Docker, using this command. Just change its path to your local path that you will store the data, so that the database can actually store the conversation. And okay, that's it. I hope you like it. Feel free to try it out, and if you have better thinking template, feel free to share also. If it work, I can add into the library so that other people can use it as well.